Okay, welcome back then. Let's have a look at question 6. Now, question 6 is, again, a skill that you may already have, but if you don't, let's take it back a step again. And let's think about what we mean when we denote a bracket, okay? So when we denote a bracket with something outside it, what we're saying is we want a quantity of that bracket. So let's take something simpler. So let's have something like 2 bracket 2 plus 3, okay? Let's break that down even further. What do we really mean? Well, we actually mean 2 lots of, and lots of is multiplication, 2 add 3. Now, in this case, we can say that 2 add 3 is 5, and you might recognize this as big maths. So do the brackets first before the multiplication. So inside our brackets, got 2 add 3. So we actually want 2 lots of 5. So that's just 10, isn't it? Okay. Now, in this case, we're missing some numbers here. We just have some algebraic terms. We have these letters again. Okay. Let's just have one more question before we get onto this one. So what if we had 2 lots of the x plus 3? Well, I can't really do anything with this bracket. I can't do anything more than say, simplify that what x plus 3 is. It just is x plus 3 until I give a number to x, and we don't know what that number is. But I still want 2 lots of it. Okay. So I want 2 lots of the x, and I want 2 lots of the 3. So the question is, how else could I have arisen to 10 here? So instead of doing 2 times 5 for this one, I could have taken 2 lots of the 2, that's 4, and 2 lots of the 3, and that's 6, and added the total together, and I still would have got 10. So I can actually take 2 lots of the individual terms, and that's the same as adding them together first and then multiplying it by 2. So let's do the same here. I just want 2 lots of x plus 3. So I want 2 lots of x, and I want 2 lots of 3. And then add them together. And that gives us our what we call an expression, 2x plus 6. So we haven't changed anything, it's just a manipulation. So how else can we write it? It's just a rewriting of the same thing, okay? And a skill which is very useful later on down the line. So let's apply the same rules here. I want x lots of x plus 3. So I want, we write it out, got x and x plus 3. I want x lots of x. Well, if we look back at question 3, we discussed this. We said that if we multiplied 2 numbers together, which were the same, that was something squared. So x lots of x, we could write as x squared. And now we want x lots of 3, which we could write as x times 3. But if you're familiar with algebra, we normally write it as 3x, which literally means 3 lots of x. We normally write the number first. And that's our expression as our answer. Okay. So moving on to question 7 then. Now for these equations, actually it's more interesting to look at what they mean if we express them using very useful English language. Okay, so what do we really mean here? Why have we got this equation? Well, what we're saying is 2 lots of a quantity, so 2 times x, and we looked at that in the last question. We had 3 times x, that meant 3 lots of a quantity. So 2 lots of a quantity that we don't know plus 3 is equal to 15. Okay, so if I gave you the worded problem, I think of a number, I multiply it by 2, then I add 3 to that number and I arrive at 15. How would you arrive back at the number that I'd originally thought of? Okay, so if we do it in reverse, I start with the 15 that I gave you as the answer. The last thing I did to my number was add 3 to it. So let's remove that 3. So let's do this backwards. Let's say, well, it was 2x add 3 equals 15. But actually, if we take away 3 from the 15, this little square, if I box that off, that 2x must be worth 12, because 12 add 3 is 15, or 15 take away 3 is 12 if we use an inverse operation. Okay, so now I arrive at 2 lots of a number is 12. So 2 lots of a number is 12, well, 1 lot of that number, which is what we're looking for us to solve an equation, well, that must be 6. Let's just try that out from the start. So I did 2 lots of 6, I'd get 12, and if I add 3, I get 15. Okay, so sometimes changing these into a worded problem helps us to arrive at the answer. So moving on to question 8 then, what's the square root of 100? Well, square root means what number do I need that has to be the same as another one in order to multiply them together and arrive at 100. So here's the question we're really asking. What times what gives us 100? Where these two numbers are the same number, okay? In fact, we could have it as x times x equals 100 if you really wanted to push it on. okay? And then that would arrive at x squared. So we've seen this before, haven't we? Something times something, which is the same number equals 100. So this equation is the same as this English statement, okay? And we would write that as x is the square root of 100. And there we go. What is the square root of 100? Well, what number do I have to times by itself to make 100? Well, that's 10, because 10 times 10 is 100. So if you know your multiplications really well, finding a square root is really easy. So for instance, if we wanted the square root of 81, well, that would be 9, because 9 times 9 is 81. Right, so next we want to convert 4 kilograms into grams. So for this, it's not a big worry if you don't know this. If we know the conversion, excellent. We can use Google to find these things out. So if you went onto Google, you might find that there's 1,000 grams in 1 kilogram. So if we now have 4 kilograms, well, that's 4 times bigger. So we can make our quantity in grams 4 times bigger as well. And we arrive at 4,000 grams as our answer. And then finally, 40 times 80. Well, here we already can say how big our answer is going to be as a factor of 10. Okay, so within here we have 2 zeros. So we already have a 10 times 10 situation. So we already know our answer is going to have 2 zeros in it. Okay, so we've moved that far away from our decimal point. We're moving along factors of 10 up through our number line. Okay, so we then do 4 times 8, we end up with 32, and we end up with the answer of 3,200. Now, I will put a warning in there. You can't just normally count zeros and put them in. If we have, for instance, decimal places, we have to be a little bit careful. But we can count the size of the number we're expecting. Okay, so we can look here and here. So we have a 10 times a 10. That gives us the 100. And then we do the 4 times 8, 32. You might prefer, before we start getting hard and loose or fast and loose with rules like that, just simply to do 40 times 80 like that in your normal conventional way and multiply that one. Okay. So for the last few minutes, I'm going to look at that extension question, so bear with me. Okay, so here's the extension question that I set right at the start. So solve this. So we're blending 6 and 7 together. Now, there's actually 2 ways of doing this, one marginally quicker than the other. So if we forget about the expansion that we did in question 6 to start with, and actually just consider this again as a worded question, what have we got here? Well, we're saying we've got 2 lots of, 2 times x plus 1, and that's 12. Okay, so actually working backwards, if we divided by 2 either side of our equation, if we boxed off our bracket of x plus 1, if 2 lots of our bracket is 12, well then surely 1 lot of our bracket, i.e. divide by 2, must be worth 6, because 2 times 6 gives us our 12. So now if I have a number and add 1 to it and get 6, well then our answer must be 5, because we take away 1 from either side. If we blend the 2 skills together, what we could do is we could expand this bracket first. So 2 lots of x plus 1 would be 2 lots of x plus 2 lots of 1, which is 2, and that gives us 12. And then now I have 2 lots of a number plus 2 is 12. So if I block this off, this value here must be worth 10. Okay, because 10 add 2 is 12, or 12 take away 2 is 10. So now we can say that my 2x is worth 10. And now 2 lots of a number is 10. So 1 lot of that number must be worth 5. Okay, and you can see in both cases we arrive at the same answer. In this one, we did slightly less work to get to that answer. Okay, so I hope you've enjoyed week 1. Week 2 will have roughly the same sort of questions. They get a bit more advanced each week. I'll pick a different question to have as the extension. And this will run through for 6 weeks. And if you need a little bit more work, we might be able to get some material through to you if you post something on Facebook to Mr. Johnson, and he can pass on any messages to me. Okay, have a lovely summer holidays.